The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. So we have come to the last part of the chapter, States of Matter. We have been learning about the gaseous state, ideal gas equation, and from that how can we derive the molecular mass formula related to the density. So today's class we are going to focus on few properties of liquid state as well, and how a gas can be liquefied, that is liquefaction of gases is what we are going to see. Now when we talk about liquefaction of gases, what does it mean? It's a process of converting a substance which is in the solid or in the gaseous state into its liquid form. That is, a substance which is in the solid or gaseous state, it's going to get converted into its liquid form is what we are going to see in the process of liquefaction. And there we have been doing several experiments and have come to a conclusion that at very low temperature and high pressure conditions, a gas can be liquefied. So then there were experiments done to find out. So a container which were containing molecules of gases were taken, and we know according to the kinetic theory of gases, the kinetic energy of the molecules are very high. So they keep on colliding with each other and also with the walls of the container. But then when the temperature is lowered, and we also know that temperature is a very important factor for increasing the kinetic energy, which means the movement of the molecules. So if the temperature is decreased, when the temperature is lowered, the kinetic energy of the molecules comes down. That is, they don't have the energy to run. So what happens? Their energy gets lowered. So their motion becomes slow, and when it becomes slow, they try to hit each other. They try to hit each other and attract each other, and once they attract each other, they, after the collision, they tend to get condensed into a liquid form. That is, they change into the liquid form. Similarly, in another situation, when the pressure becomes so high, that is, when you compress a gas, when there is a high pressure applied, the gas molecules, they come closer to each other. So what happens is that they have minimum space between each other, they collide with each other, and again they tend to change into its liquid state. So these are the primary two conditions for a gas to get liquefied at very low temperature and high pressure conditions. One Mr. Thomas Andrews was finding a relationship between pressure, volume and temperature of a substance in gaseous and liquid form. So how did he conduct this? He took a gas, for example carbon dioxide, and he plotted the graph against the pressure at different temperature, that is at constant isotherms. Isotherm, you know, similar temperature. So the graph was plotted for carbon dioxide at different temperature being constant against the pressure. What happened then? At high temperature, when the temperature was high, the gases start to behave ideally. Even the real gases started showing ideal behavior. But then we came to a conclusion that even when the temperature or the pressure is being altered, the gases were not able to get liquefied. They were not able to find out that exactly at what particular pressure or temperature a gas can get changed into its liquid form. Carbon dioxide, when it was drawn at a different temperature level, at up to 73 atmospheric pressure, it was behaving like a gas. So carbon dioxide was a gas up to 73 atmospheric pressure. But at 73 atmospheric pressure, what happened? Slowly the liquid carbon dioxide started to get appeared. Carbon dioxide from the gaseous state getting changed into its liquid form. And at 30.98 degrees Celsius, there was a temperature where the carbon dioxide gas was exactly in its liquid form, and that temperature we call it as a critical temperature. So critical temperature is a temperature at which the gas tried to behave like a liquid. Above the critical temperature, carbon dioxide is no more a liquid, it is again a gas. The volume at that particular time, volume of 1 mole of a gas at that particular Tc, that is critical temperature, we call it as a critical volume. At that particular critical temperature, the volume of 1 mole of carbon dioxide is called as a critical volume, and the pressure is called as a critical pressure. So critical pressure is a minimum pressure above which the gas can never change into its liquid form. So the critical pressure, critical temperature and critical volume, these three are called as the critical constants. And then you are having in your textbook about the important conditions of a liquid state, like how a liquid is getting transformed into the various states of matter. So those things we will now go through, and also about the properties of liquid. Liquefaction of gases. The process of converting the substance in solid or gaseous state into a liquid state is done by two processes, that is by lowering the temperature or by increasing the pressure. According to kinetic theory of gases, the kinetic energy of gas molecules are very high. As the temperature is lowered, the kinetic energy of the molecules will decrease. Consequently, the molecules come closer to each other, attract each other and get converted to the liquid form. So you can see here gas is getting converted into the liquid form down there in the beaker. Similarly, when the pressure is high, that is when you push the piston down, the molecules come close to one another. As pressure increases, force of attraction between molecules becomes stronger, and consequently the gases changes to the liquid form. So that is the effect of increase in pressure. Thus, gases can be liquefied by increasing the pressure or by decreasing the temperature, or the combined effect of both. The pressure-volume temperature relationship was studied by the scientist Thomas Andreas, where he believed that real gases behave in an ideal manner like carbon dioxide, and so he plotted a graph of carbon dioxide with pressure at various constant temperature, and this was called as isotherm. From the graph, at high temperature, the isotherms plotted for carbon dioxide is similar to that of an ideal gas. This means the gas cannot be liquefied at higher pressure. The graph shows at low temperature the shape of the curve changes, or in other words, at low temperature isotherms show deviation from ideal behavior. At 50 degrees Celsius, the isotherm of carbon dioxide is very similar to that of an ideal gas. At 30.98 degrees Celsius, the carbon dioxide remains as gas up to 73 atmospheric pressure. Now, if you see the graph clearly, at a pressure of 73 atmospheric pressure, the carbon dioxide tries to change to the liquid form. Now this pressure is called the critical pressure of carbon dioxide. It is the minimum pressure required to liquefy the gas at a critical temperature. Similarly, 30.98 degrees Celsius is the highest temperature at which liquid carbon dioxide appears. This temperature is called critical temperature, which is the temperature above which a gas cannot be liquefied however high the pressure may be. The volume of 1 mole of a gas at critical temperature is called the critical volume. So it is the volume of 1 mole of a gas at its critical temperature. Let us look at the behavior of carbon dioxide below 30.98 degrees Celsius. At 21.5 degrees Celsius, carbon dioxide isotherms, you can see it has been divided into 3 parts. It consists of 3 parts. At point A, carbon dioxide is a gas, after which the volume of the gas changes along the line AB. That is, it decreases the increase in pressure till the point B. At point B, it appears liquid at a particular volume. When the gas is compressed further, the pressure does not change. The liquid and the gas form coexist. As the pressure increased further, more gas is getting condensed at point C. Line BC, there is a considerable change in the volume with pressure. Now, the isotherm rises slowly as there is a change in the volume and the pressure. Thus, CD indicates reduction in volume of the gas, and it shows that there is a very high pressure required to compress the liquid to a smaller volume. So this graph shows exactly at what particular temperature and pressure or the volume a gas can be liquefied into its liquid form. Above that particular temperature or pressure, the gases cannot be liquefied. So this is an example of carbon dioxide gas which shows the ideal behavior. Let's see the summary. Thank you. We are going to see something about liquid state. We know liquid is one of the 3 states of matter, and here the molecules are neither so close to each other nor they are very free to move. Of course, they are not attracted to each other or separate from one another. That's why liquid takes the shape of the container and has a volume also. When we talk about vapor pressure is most important because liquid, when it is boiled or heated, it changes into its vapor form. Such pressure exerted by the liquid, we call it as equilibrium vapor pressure or saturated vapor pressure, where the vapor pressure of that is a liquid, when it boils, when it changes to its vapor form, there will be some vapor pressure exerted by that vapor. We call them as equilibrium vapor pressure, which lies between the liquid and the gaseous form. What is boiling? When I keep a liquid or water in a vessel and heat it, it does not boil immediately. We know the heating takes place first. When you touch at the top, it will be very hot. When you touch inside in the middle, it will not be that hot. So the molecules, they just interact with each other. So whichever has been heated up, they come down, and the next particle, they go up. Right. So that liquid, when it changes to the vapor, we call that as boiling. So what is boiling point? Temperature at which the vapor pressure of the liquid becomes equal to the external pressure. External atmospheric pressure, which is equal to the vapor pressure of the liquid. Every liquid has a particular vapor pressure. When that becomes equal to the external pressure, we call that temperature as a boiling point. 1 atmospheric pressure is called as a normal boiling point. The temperature of 1 atmospheric pressure. When it is 1 bar is also used for pressure denotion, that we call it as a standard boiling point. It can come in 1 mark. So 1 bar and 1 atmospheric pressure both are used for denoting pressure, but 1 bar is slightly less than 1 atmospheric pressure. Now there is a temperature which we call it as critical temperature. What does it mean? Now when the liquid is heated, it does not boil immediately, does not convert all the liquid into its vapor form. So when a liquid is heated, you cannot see a clear boundary between a liquid and the vapor form. But after some time, because liquid being more denser than the vapor form, it will be there without any separation. But later, as the temperature increases, all the liquid has been transformed into its vapor form. So the density of the vapor actually rises. So when the density of the vapor rises, there will be a particular temperature where you could see a boundary of the liquid and the vapor. There will be a liquid vapor boundary clearly seen. That particular temperature we call it as a critical temperature. So critical temperature is a temperature where you can clearly see, or it is visible that there is a separation between the liquid and the vapor form. These are the main things that we are learning about the liquid state. Now why does these things happen? Because there are few properties that the liquid possesses. One of the important property is the surface tension. The tension or the attraction or the pull that takes place at the surface of the liquid. Now you have seen several examples like why the molecules they appear spherical in shape, mercury drops, or why there is a rise of liquid in the capillary. Now all these are because of the property that they exhibit is the surface tension. Now what is surface tension? You have a beaker, a container where there is water present inside. Molecules are at the surface level and also in the bulk which is inside. Now when the molecule is inside the bulk, there is attraction taking place from all the sides. All the sides there is an intermolecular attraction. But the molecule which is present at the surface, there is no attraction from the top because there are no molecules there, but only from the bottom, that is from the bulk, there is a pull, there is an attraction from the bulk for the molecule which is present on the surface where they pull towards the bulk inside. Such property we call it as a surface tension. Now the energy required to increase the surface area of the liquid by 1 unit, we call it as a surface energy. So we have special units for that, and this surface tension can be increased by increasing the total size of the particle, size of the liquid substance, or by decreasing the temperature, because when you increase the temperature again kinetic energy becomes more. So what happens? Random movement and the surface tension actually decreases. You will be seeing the video with animation to understand what is surface tension very clearly. Now we will get back to the last topic, which is viscosity. The last topic which we are seeing for today's class is viscosity. We have been hearing this term from long back, viscous. Viscosity is a property of a liquid where there is a resistance to flow. We know fluids are nothing but which can flow easily. So even we call gas as a fluid. So liquids are special fluids because they have a tendency to flow. So when there is a resistance to the flow, because of the internal friction between the two layers are there, the top layer and the bottom layer, there is a resistance to flow because of the friction. Such property we call it as viscosity. Now you have a video for viscosity where you will be seeing there are different layers, where each layer, say assume that there is a top layer which is running over in contact with another layer. The molecules in this layer remains stationary, they don't move. But the molecules in the moving layer, they tend to change its velocity because of the contact between the stationary layer and the upper layer. That velocity we call it as a velocity gradient, change in the velocity. So we know force that is applied, the frictional force that is applied over a particular area of the liquid is directly proportional. which is equal to A into du by dz, change in velocity. So to remove this proportional, we introduce a constant which is called as eta, which we call it as coefficient of viscosity. Coefficient of viscosity is the force which is acting on a liquid having a unit area of cross section and a velocity of 1 meter per second, which is traveling with a different force. There are different forces which are used for increasing the viscosity of a liquid. These are hydrogen bonds and van der Waals forces. Van der Waals forces are very weak forces which tend to make the liquid flow very slowly, and also the hydrogen bonding. Glass is an example of a viscous liquid. And also if you want to increase the viscosity, you should decrease the temperature, because as the temperature increases, we know kinetic energy of the molecule increases, molecule gets more energy. With intramolecular attraction, they tend to move faster. So these are the important terms which related to viscosity. We don't have this derivations and all, you don't have to learn it by heart. Just have to understand what is viscosity, its unit, what is coefficient of viscosity, and what are the factors that can affect the viscosity. I will be playing the video definitely, children, for you to understand. Once this chapter is over, I may not be going immediately to the 6th and 7th, because those are problems related and that may take so much time. So what we will be doing is, we will be focusing on the topics which we have for +2. Like from the 8th chapter onwards, like redox reactions and hydrogens. So those chapters we will be just focusing in the next class. Thank you, children. Have a great day. Take care. Liquid state, surface tension and viscosity. What happens when we add oil to water? Do they mix? No, they do not. Do you know the reason why? Why mercury does not stick to the wall of a thermometer? Or how are the spherical shaped dewdrops formed on the leaves? The reason for all such questions is the property of a liquid, which is surface tension. Surface tension is equal to the amount of force per unit area needed to expand the surface of a liquid. Cohesive forces between the molecules at the surface of the liquid and at the bulk of the liquid. There is a difference between those cohesive forces between the molecules. Molecules in a liquid experience cohesive forces from all sides. That is, the molecules which are in the bulk. The molecules at the surface of the liquid experience a net attractive force which is downwards towards the liquid. Liquid tends to minimize their surface area. Molecules at the surface have more energy than the molecules in the bulk as they experience a net downward force. The energy required to increase the surface area of the liquid by 1 unit is the surface energy. This energy is needed to break the surface tension and remove a molecule. Such energy is called as the surface energy. When a liquid comes in contact with the surface, both cohesive and adhesive forces act on it, which governs the shape of the liquid that it takes. Let us quickly check our knowledge. You can just go through the slides. Just read these questions and try to get the answers. When you explore, definitely you will be able to get the answers for these questions. I hope you can pause the video and get the questions done. We will get into the next property of the liquid, which is viscosity. Have you experienced any resistance when we move our fingers through a liquid? This happens because of the frictional force that opposes the movement in a liquid, which is viscosity. Viscosity is one of the important characteristic property of a liquid. The measure of a liquid's resistance to flow. It arises due to internal friction between the different layers of a liquid. Viscous force is the force between a surface and a liquid that flows past it. The movement of a liquid is resisted by the friction between the liquid and the surface it flows along. Friction and viscosity are directly proportional to each other. Let us now learn how viscosity is measured. Viscosity can be measured using a simple formula as follows. Though we don't have this in our syllabus, it is just an extra bit of knowledge for us to learn. So viscosity can be calculated using the formula shear stress by shear rate. We don't have these graphs for our syllabus. You just have to know about what is shear stress and what is shear rate, which is the force per area, that is Newton per meter square. So using shear stress and shear rate, we can calculate the viscosity of any liquid. Let us now quickly learn about the factors that are affecting the viscosity. Some of the factors that affect the viscosity of a liquid are temperature, pressure, concentration, attractive force and particle size. Let us learn one by one. Temperature. Viscosity of a liquid decreases with increase in temperature and vice versa. The viscosity of a fluid actually decreases because as the temperature increases, the kinetic energy of the molecules are more, and so they can move easily. Lubricants tend to be thicker or more viscous when cold and less viscous or thinner when it is hot. Viscosity of a gas increases with increase in temperature. Now pressure. Viscosity is directly proportional to the pressure of a liquid. That is, the fluid viscosity increases with increase in pressure and vice versa. So you can see the graph here. As the pressure increases, the viscosity of the fluid is also increasing. Next, let us learn about concentration. Concentration is the amount of a substance dissolved in a specific volume. When concentration of substances increases, viscosity of liquid also increases. Example, honey comprises of glucose and water. Higher the concentration of glucose, higher is the viscosity of glucose. Attractive forces. If attractive forces are stronger among the molecules of a liquid, it is difficult for the particles to pull away from each other. The liquid thereby is more viscous, and this property is important as it is used in the pharmaceutical industry who works on the manufacture of ointments, cream and simple liquids. The last is the particle size. The size of the particle is directly proportional to the viscosity of a liquid. This property of particle size is important for creating biopolymers in specific way in certain conditions. So more is the size of the particle, higher will be the viscosity. I hope you understood all this about the liquid state.